the next 20 minutes, we'll talk about how to accelerate the work you're doing on NSO using the capabilities in CNC. So my name is Nisbet Tisell, NSO product manager for quite a long time. We have Deepak, CNC PLM, and Sujay, our superstar TME. So let's move on to what we will cover about in the next few minutes. If we go to the next slide. So, of course, what is CNC? But the interesting thing here we'll talk about today is actually how to tie your current work in NSO to the CNC components and functionalities, and how to accelerate the pathway, how to reach to use the combined stack for closed loop automation as an example. Sujay will talk a lot about how this looks like for you as a developer, and of course, we'll summarize that in the end. So that means that I now hand it over to you, Deepak. Let's hear about CNC as a start.
So, as many of you may know, CNC is the SDN controller for the IP transport domain spanning across right from the data center edge all the way to the access. So what it brings together is integrated service and device lifecycle management in a single solution under a single pane of glass. From the device lifecycle manageability, it's really the core function. When you are managing a network, you need to have capabilities like ability to look deeper into the inventory, be able to collect the false performance, making sure the network is performing well, ability to upgrade the software devices, as well as onboard the devices with very little effort, what we call as device onboarding with zero touch provisioning. And of course, being able to push the config. So those are really the core function you must have. But then when we talk about the service lifecycle, those are the functions which helps elevate the value proposition and ties the manageability, automation to the business outcomes. And that is where we manage the entire lifecycle of the services that you're delivering, right from the provisioning of services, whether it's L2 and L3 VPN services, visualization of topology, and different overlays to help ease the manageability of the network, then be able to optimize the network as well as monitor those services, which is quite key, just to make sure whether the service is up, running, and doing that process that takes advantage of a lot of innovations in the platforms like circuit style or flexible algorithm to be able to make sure that you're delivering the service level objectives that are associated with the service. And I'm going to go a little deeper because the goal of this session is not just introduce CNC, but really to how do you elevate the value proposition and still offer an immense opportunity to actually do customization and extensions and elevate the value. So in all these capabilities are accessible through single pane of glass. And one of the key principles that we actually implement in this solution is being open and standard space. So that enables the controller to work with any of the devices that embrace the open standards. And also what we embrace is the API first principle, where it makes the product very programmable, extensible. It can enable through REST and RESTconf API integration with northbound systems. And also it enables a lot of customization and extension of work that is really relevant. And we're going to talk a lot more about it in this session. So now let's go through the progression of automation. Going to the next slide.
Thank you. So for those of you who are used to use NSO, we have here the different stages where we see typically our customers and users are progressing through the maturity or life cycle or automation journey, so to say. Starting at stage 0, really starting with CLI focused. When you use NSO, you can see NSO as a network-wide CLI. All know about that. And if you don't use NSO in that stage, you typically maybe do some thing as we call adaptive scripting in stage 1, where you're starting to understand how to actually do choices and selections and decisions on a very simple way. And at this level, we will see that NSO is a network abstraction where all the devices and the capabilities of the devices are exposed by the NEDs, still there was some simple scripting on top of that. Now when we're talking about stage 2 here, and model-based is the starts getting interesting, where we actually use the YAR models not only to describe the capabilities of the device, but also to describe the intent of the service, where you want to go. And here is that you describe intent, NSO calculates the route to the intent, like a GPS from London to Paris. You only need to focus on where to go. The machinery calculates the route there. You don't need to make the decision in every turn. Stage 3 for NSO is then, of course, the life cycle of the network services, service awareness in the sense of NSO manage the life cycle of the service provisioning, both for create, update, delete operations. And then when we add CNC to this.
Yeah. So talking about or elaborating more on what Niels presented earlier. So how do we take some of the work that you're doing on NSO and elevate it to drive more and more business outcomes? So I'm going to kind of walk through this journey as you progress across the different stages in the automation maturity graph, right? So as Niels mentioned, the first step like you're doing is building a lot of scripts to be able to automate the provisioning or the configuration of the devices, services, and so on. But what adds a significant value on top is when you start to visualize the network, you start to see the topology, you understand where are those devices and links in the network that I'm actually provisioning? What's the outcome of that? And that you can see when you start to overlay some of the element management capabilities in the CNC, where I can look at the topology, I can look at the changes in topology, I can look at the faults, I can look at the KPIs. And also, if you're writing some of the scripts at this stage, how do I orchestrate the execution of those scripts in a more, workflow manner? And that's where the integrated workflow engine that's coming soon in the CNC comes into play. And that offers significant opportunity in this stage itself from the developer perspective, where if you were to support the abilities like the device management, you could develop custom device packs if, for example, the devices are not conforming to the standards for communication, or being able to customize the dashboards, or be able to create the workflows for the orchestrated script execution. Going to the next stage, so when Niels mentioned about the device-based approach, the models-based approach, and what the models-based approach also brings is what we call as declarative approach. And when we say declarative, it's about programmability. And in the CNC, it's embracing that intent-based approach or model-based approach across the full operational lifecycle, right from provisioning to monitoring or service health monitoring or to optimization. So again, it offers, from the developer perspective, the ability to extend some of the service models, adding attributes based on what you may need in your network. Let's say if I want to add QoS attribute or other attributes, or be able to develop a heuristic model. We'll talk a little more about it. How do I build that model to be able to relate my service, underlying sub-services, and what metric I need to collect based on the best practices for the service health monitoring. Going to the next level up further, when you become more service aware, I start to now enforce or monitor some of the service level objectives. And not just at the service level, I want to tie the service to the device lifecycle as well, where if there is a service degradation, for example, I would need to be able to, I could just go down, drill down, navigate to figure out what could be causing in my network that service degradation. And as you are managing the services, from operational or from developer perspective, you can now onboard the brownfield services, which could have been created by CLI, but now you can actually discover, onboard them in CNC and manage the lifecycle in CNC. You can use SDKs where I can extend how the services could need to be visualized. And then NBI integration. I mean, CNC is the domain manager for the transport domain. So it's a wealth of information, mine of data that you can now take advantage of, gather the data and build additional capabilities. And as we get to the predictive and preemptive stage, that's where the self-healing capabilities comes in the picture, like self-optimization, where once you define the intent, the network can now make sure that it preserves the intent. How does it figure out there is a need for optimization. How does it figure out there is congestion? Those can still, from programmatic perspective, can be fine-tuned. And then, of course, getting the closed loop automation with the integrated workflow engine that's, again, as I mentioned, coming soon, it offers the ability to create custom KPIs as well as custom MOPS workflows to be able to implement the actions that are needed to do, whether it's remediation, maintenance, such kind of workflows. So I'm going to go a little deeper in some of these use cases where I'm going to talk about how we address, how we embrace the intent-based approach. Going to the next slide. So when we talk about this acceleration of automation, there's no one recipe. Every deployment has its own priorities, has its own target use cases. So with the CNC, there are different pathways for accelerating automation. So if you are on NSO, and the first step you may want to do is to just use the capabilities in CNC, which is to visualize the topology and element management capabilities, where I can overlay fault performance data right on the topology along with the NSO deployment. And then based on the rollout plans and the target use cases, you can take the path of service and underlay transport visualization, where I can now overlay it on the topology. I can start to look at the services and ability to navigate down to the underlay transport, or doing dynamic traffic engineering, which is again intent-based, or service health monitoring, where I can extend the service models to also include what I need in terms of provisioning the instrumentation, the probes to collect the data and be able to automate the characterization of the health of the service, as well as allows you to figure out if there is a degradation where in the network it could be caused. And then going up further in the maturity levels, then you can start to implement the closed loop automation right from optimization to maintenance to remediation. Going to the next slide. So going a little deeper in terms of specific use cases. So this is the first one, which is the real-time network visualization. And this is a huge value proposition from the operational perspective, because I can now see my network end to end. I can look at the topology, changes in topology. I can overlay performance, health. I can go deeper in terms of the inventory, all the way to the line cards, pluggables, chassis levels. And the outcome is that it helps to look at the network end to end. I could have different teams managing different parts of the network, but this gives the ability to look at the network end to end. Now, as I mentioned before, the opportunity from the development perspective is if I were to support multi-vendor devices or devices that are not supporting standards-based, protocols, then I could build some device packs or adapters to be able to connect to those devices. I could customize the dashboard the way I want to see it from operational perspective. Going to the next use case. Service and underlay transport visualization. Again, here we embrace that intent-based approach where we use the declarative model, where I can specify the intent of the service in terms of whether I want it to be low latency, I want it to be adhered to certain constraints like affinity or path disjointness. And when we have that kind of concept, again, from the developer perspective, it gives you the ability to extend those models, to customize those models based on the specific service definition or SLOs that you want to implement in the network. Going to the next slide. And this gives you a view in terms of how you can even onboard the services. Already a capability in CNC is that if a service has already been deployed using the model-based approach in NSO, how I can onboard it in the CNC. And also not just if you have a service deployed in NSO, but if there are services deployed with CLIs, the capability that's coming in the next release helps you to discover those services, onboard them. Again, that requires some of the programming that's needed. And of course, this expects that the services are modeled using the ITF standards. Going to the next one. Dynamic traffic engineering. This is another example where we have declarative intent-based approach, where we define the service objectives. whether it's minimization of IGP metric, T metric, minimizing the latency on the network. And this becomes really important because the network is dynamic and we can't manually keep re-optimizing the network. It doesn't really scale, and it adds risk to the SLAs for the services. So in this case, once you define that intent, the network takes care of detecting if there are issues in the network and then be able to re-optimize fairly quickly. And that, again, from developer perspective, you can fine tune the algorithms that actually make it happen. Going to another use case, and that's a service health monitoring. And in service health monitoring, it's about being able to detect whether the service is up or running, up or down or degraded, and being able to figure out, like, if the service, what is causing that service degradation from the control plane database data plane component perspective. And again, here, the opportunity from the development perspective is to be able to define those heuristic models that helps establish the relationship between the service, underlay, data plane, and control plane components. And based on the best practices, what metric I need to collect to be able to characterize those services. Now I'm going to hand it over to Sujay to actually walk you through some of the programming examples in automation.
Hey, thanks, Deepak. Thanks, Niels, for the introduction. So, folks, as we have seen here with the opportunities in what key strength and capabilities from a developer's perspective is, yeah, as Umar started with, yeah, we have NSO, we have all the good things there. Like, can I extend this beyond to those various use cases that Niels and Deepak walked through? What I want to cover here are those aspects of how in various stages can you do customization or extension. So I'll start with the first one is on the stage one, where you would like to do some of your adaptive scripting for device customization. So CNC is that single platform to build your common models, which is the inventory discovery in this case, where the discovery models can engage with the corresponding data collectors that deploy those data collection functions. And what I mean by the data collection functions is, for example, on the right-hand side, you can see an example for a non-Cisco device, how we could build a performance monitoring capability through the device inventory packages that uses the OpenConfig sensor paths to subscribe to that and generate those performance metrics for the specific router. So on CNC, we can currently look at Cisco's devices features, but you could also build those common models for the third-party devices into a single platform to then build your custom packages that will consume from these device package features. And these are available as part of XAR bundles, Java and Python libraries that can be enabled, deployed in your instance, built once, and then reused multiple times. On the second use case is where we would like to see is the model-based customization and extension. Now, in this case, where you have your current data models, your NSO function packs, service models built for various use cases. How do I integrate this into CNC is an example here to say on the CNC cat service metadata.json that has the paths to the service, the plan, which is the plan notification intent from NSO, your labels, the labels that is where on the CNC UI does the provisioning determine them, and what is a service type label. I mean, you could build your own type labels. As you can see, layer 3 VPN service and layer 2 VPN service are something out of the box, and I can build my own layer 3 VPN service type label to build all those service type capabilities if I'm using a service path from the NSO's service models that have been developed. And I can then extend this to the service assurance path that I'll show in the upcoming slides. Is now I have those services, how can I build the inventory collection of the services? That is, tell me what is the life cycle of the service. And I can also build into the next use case is how do I visualize those services? Now, for example, on a use case for a layer 3 VPN example, you can define if you have a route target, if it's a V4 or a V6 type, which is a caption. And there are Java parsers that on the overlay test parser, you can define for what is the caption, what's the decoration to be defined, that is, what is the route target ID, and then the direction, if they are both import and export, or it's only one way, and you can determine the arrow based on the plugins. So this is an example of an overlay plugin that tells you what the overlay parsers can achieve through the various service model paths and what is the intent derived from the service. Moving on into your service-aware customization, right? The extensions are to create your service level capabilities. Now, for example, when we start with your own NSO service models, you visualize them on CNC. What's next? Like, how could you extend this into your stage 3 is to do service awareness. Now, this is an example of a heuristic package where I'm defining a custom namespace called custom, and the config source is determined from NSO. That is the service model that was developed. And sorry, and the service model will build from the match expression of layer 3 VPNs, extract the value, the name of the service, name of the VPN name, the endpoint, and the version. So newer version will help you modify. You can build, customize, update your revision version, push that into the system, and then your service assurance will start collecting once you enable your heuristic models collection from those various entities that ties that to the device intent. So for example, in this case, I want to monitor the layer 3 VPN, and on a specific node, I want to know what is the interface health state, the PSEP session health, or the BGP neighbor health. What is the SR policy if that is configured, and so on, right? So the VRF route health information. A lot of this information is available on the network. It's after the provisioning that as a day 2 operation, I want to start monitoring the SLA for the service so that I can know that in an event of a degradation, I can pinpoint it to actually where the issue occurs and lies. But moving on to service awareness, right? I think once you've created, now you can say that for your service types, layer 3 VPN, I need to have a custom profile. That is to say predictive and preemptive customization, right? Where I'm saying, okay, show me what is the delay threshold. Show me the SRPM delay threshold for 25 milliseconds for a service. So I can build those customizations by building these various config profiles. So for example, if you see here on the left, I have different config profiles for a layer 2 VPN and a layer 3 VPN using the same service model, but defining different SLA or a delay threshold parameters. That says for layer 2 VPN, what is the delay threshold? And for layer 3 VPN, what is the probe delay threshold in this case? And I'm monitoring that on the CNC when I'm collecting the stats through a policy where it is running the performance metrics, and I can mark the service as either healthy or degraded based on the SLA to say like, okay, has the maximum threshold for a delay exceeded 25 milliseconds or not? If it has, then mark them as degraded. Although everything is good with provisioning, service is visualized, I can see the paths, but the round trip or the end-to-end delay that's being resulted is because of some path optimization changes, and that's where I can monitor and predictively make some changes on the service or the network. Now, the last part is in the overall journey, right? What we have seen here in the overall use case journey is how to build your own closed loop automation use cases. Now, this is a sample example to say, I want to log into CNC, get a metrics for a particular interface stats, run a bandwidth utilization check. If a bandwidth exceeds a certain threshold, then I want to push a peering policy, which is a QoS policy, to rate limit that to 3 megs. That's an example that I'm saying. So I'm attaching this based on a workflow, and the workflow, I think in the upcoming session that you would see how are the key capabilities for workflow, but I can build this on the workflow manager to get the metrics using the CNC's API. That is, this is a CNC API example that tells me what is the metric that I need to fetch between a link, what is the outcome that I would get, and then the bandwidth utilization query on the workflow manager will filter for this bandwidth utilization. And if it finds that this value exceeds the threshold, which is like 9 megs in this case, is too much of the utilization that I don't want to exceed, which is 90% of utilization, it will then, if it matches this exceeds excessive bandwidth utilization, it will push this internet peering access service to the node. Right, so this is using the key capability. So on the workflow, I'm creating a set of peering set, login, reset, but I'm running the monitor link bandwidth utilization workflow to build my closed loop automation use case. And eventually, if the rate or the packets drop has reduced, it will reset back, which will remove the QoS policy back from the network. So these are some of the use cases, examples that you could build into your automation and orchestration journey, simplifying operations. But nevertheless, I know this is an evolving journey, and the approach is for the broader automation opportunities to leverage what are the out-of-the-box key capabilities. We understand every customer have different needs. There is always a need for customization, extension, reusing what is already being available. So multiple acceleration pathways. You can start at a particular stage that you are with NSO, extend with CNC, all the way achieve through closed loop automation, flexibly aligning with what are the target use cases, right? How can you roll out your automation plans in your journey and have CNC that can accelerate this closed loop automation use cases? I know we've been here for a short time, but I know this session proves to be useful and helpful, but I want to call out we also have the opportunity that you can participate in the hands-on lab sessions, which is upcoming on day 3. So if you guys have signed up, we'll look forward to seeing you there.